know I came through with the fuego. You know I came through. Hey, you know I came through. You know I came through with the fuego. You know I came through. Hey, you know I came through. Nowadays, I cannot lay low. I cannot lay low.
Yes, welcome to our MMW or Mathematics in the Modern World subject. And we are now in Chapter 1, Nature of Mathematics. So topic for today is Patterns and Numbers in Nature and the World. In this video lesson class, we will be looking at different patterns and regularities in the world and how mathematics comes into play both in nature and in human endeavor. So what is a pattern? Patterns are regular, repeated, or recurring forms or designs. For example, layout of floor tiles, designs of buildings, or the way we tie our shoelaces. Studying patterns help us in identifying relationships and finding local connections to form generalizations and make predictions. For example, in this case, which of the figures can be used to continue the series given below? So the base figure rotates at an angle of 45 degrees in the counterclockwise direction. Hence, choice C is the perfect match. Let's take a look again. So it's just moving on the counterclockwise direction at a 45-degree angle. Next, which of the figures you think best fits the series below? Okay, the base figure rotates at an angle of 90 degrees in the clockwise direction. Hence, choice A is the best fit. So let's look at it again. So it's just moved 90 degrees at a clockwise direction. So the best answer is letter A. How about this one? Which of the figures can be used to continue the series given below? Okay, in the given series, a figure is followed by the combination of itself and its vertical inversion. Thus, letter D is the right choice. Okay, let's look at it again. Okay, next, which number comes next in 1, 3, 5, 7, and 9? Okay, the sequence is increasing by 2. The answer is 9 plus 2 equals 11. So 1 plus 2, that's 3. 3 plus 2, that's 5. 5 plus 2, that's 7. And 7 plus 2 is 9. So 9 plus 2, the answer is 11. Next, which number should replace the question mark? Do you observe the pattern? Okay. For each row, the sum of the first two columns is equal to the multiple of the last two columns. So the answer is letter A. Let's take a look at it again. So here, 17 plus 8, it is a multiple of 5 times 5. Or the factor of this, the sum of this number can be found here in the last two columns. Next, 13 plus 7, that's 20. So the factors are 5 times 4. Next, 6 plus 12, that's 18. And the factors are 6 times 3. Next, 10 plus 6. And the factors are, okay, so the answer is 4. Okay, can you try this one, class? Okay, the correct answer, beginning with 3, each number in the series is a square of the succeeding number plus 1. So the answer is 7 squared plus 1. The answer is 50. Did you get it, class? So here is starting with 3, 3 squared plus 1, that's 10. In here, 4 squared plus 1, that's 17. And in here, 5 squared, that's 25, plus 1 is 26. And in here, 6 squared plus 1, so 36 plus 1, that's 37. And the next is 50, so that's 7 squared, 49 plus 1, that's 50. Try this. Which letter comes next in the given pattern? A, C, E, G, I. Can you figure out? Okay, the pattern is skipping up one letter in the alphabet, so the answer is letter A. So A, B, C, then C, D, E, then E, F, G, then G, H, I. So the next letter is J and then K. So the correct answer is letter A. Next, symmetry. Symmetry indicates that you can draw an imaginary line across an object and the resulting parts are mirror images of each other. Examples are in the butterfly, in Leonardo da Vinci's Vitruvian Man, or in a starfish. The butterfly is symmetric about the axis indicated by the black line. Note that the left and right portions are exactly the same. This type of symmetry is called bilateral symmetry. Another example is in the Leonardo da Vinci's Vitruvian Man. It shows the proportion and symmetry of the human body. There are other types of symmetry depending on the number of sides or faces that are symmetrical. So for example, in a starfish, note that if you rotate the starfish in figure 3 by 72 degrees, you can still achieve the same appearance as the original position. This is known as the rotational symmetry. The smallest measure of angle that a figure can be rotated while still preserving the original position is called the angle of rotation. A more common way of describing rotational symmetry is by order of rotation. A figure has a rotational symmetry of order n or n-fold rotational symmetry if 1 over n of a complete turn leaves the figure unchanged. To compute the angle of rotation, we use the formula 360 degree over n. So for example, in this figure, as seen in the figure 4, the pattern on the snowflake repeats 6 times, indicating that there are 6-fold symmetry. Using the formula, the angle of rotation is 60 degree. Do you wonder why bees use hexagon in making honeycomb and not any other polygons? The reason is that more area will be covered using hexagon compared to the other polygons. The following computation prove this. Next, packing problem. Packing problem involve finding the optimum method of filling up a given space such as cubic or spherical container. So we have a claim here. If hexagonal structure is used, then more area will be covered. So let's have the proof. Suppose we have circle of radius 1 cm, you, each of which will then have an area of pi square cm square. So using the formula for the area of circle, and that is pi r squared, so the radius is 1, so the area is pi square centimeter for this circle, which are then going to fill a plane with these circles using square packing and hexagonal packing. So for the first one, let's have the square packing. So we have here a square having covering the two radii of the circles. So the side of the square is 2 centimeter. For square packing, each square will have an area of 4 square centimeter. So since the side of the square is 2, so using the formula for the area of square, and that is s square, so 2 square, that's 4 cm square for the area of the square. Note that from figure 6 that for each square, it can only fit one circle. The percentage of the square's area covered by the circles will be, so one circle, the, why is it one circle? Because we have here one port for each circle. So one port for the area of circle times 4, and that is area of one circle. So to compute the percentage, area of the circles over area of the square times 100%. So substituting the area for circle, and that is pi square centimeter over the area of the square is 4 square centimeters. So times 100, approximately that is 78.54%. Next, for hexagonal packing, we can think of hexagon as composed of 6 equilateral triangles with side equal to 2 cm. Okay. So for this figure, in figure 7, for hexagonal packing, so imagine that the hexagon is composed of 6 equal, 6, 6 equilateral triangles. Ayan. So the side of each triangle is 2 centimeter as the side of the hexagon covering the two radii of the two circles. So we will use this formula to compute the area of the of each triangle. So this formula is used when we know the side of equilateral triangle. So square root of 3 over 4 times the square of the side. So substituting the side of the triangle, so square root of 3 over 4 times 2 square. So the answer is, cancel this. So the answer is square root of 3 square centimeter. So since, look at the figure, we have 6 equilateral triangles. So the total area of the hexagon is 6 times square root of 3 square centimeter. Looking at the figure 7, there are 3 circles that could fit inside one hexagon. So the whole circle is in the middle and 6 1/3 of the circle. So for the area of circle, so here is one whole circle, and this, we know that the angle of this, the interior angle of the hexagon is 120 degree. So whole circle divided by 120 degree. So we can only get the 1/3 part of the circle. Okay, so 1/3, 1/3 part of the circle, ayan, so times 6, that is 2, plus the area of one whole circle, so that is the total area of the circles is only 3 pi square centimeter. Ayan. So the percentage of the hexagons covered by circles will be area of the circles over area of the hexagon times 100% equals, substitute the values, 3 pi cm square for the area of circles over 6 square root of 3 square centimeter for the area of hexagon times 100. So approximately that is 90.69%. So comparing the two percentage, we can clearly see that using the hexagons will cover a larger area than when using squares. Next, other mathematics in nature and the world. According to Alan Turing, a British mathematician, the formation of hyena spot and tiger stripe is covered by a set of equations. What Turing proposed was that there are two chemicals interacting inside the embryo of an animal. He did not know what these chemicals were, so he named them morphogens and proposed that they reacted with each other and diffuse through the embryo according to a system of reaction diffusion equations. So other examples of mathematics in nature are the Fibonacci numbers on flowers and Nautilus shell. So those patterns in flower and in shells. And another example is mathematics used to model population growth with the formula A equals P times E raised to RT, where A is the size of the population after it grows, P is the initial number of people, and R is the rate of growth, T is time, and E is the Euler's constant with an approximately value of 2.718. In your calculator, you can find the number E. So that's a constant number equivalent to 2.718. Example of applying the mathematical model in population growth. The exponential growth model A equals 30 times E raised to 0.02t describes the population of a city in the Philippines in thousands, T years after 1995. Question number 1. What was the population of the city in 1995? So the solution is, since our exponential growth model describes the population T years after 1995, we consider 1995 as T equals 0, and then solve for A. Thus, A equals 30, and the city population in 1995 is 30,000. For the computation of number 1 problem in exponential growth, so we have 30 times E raised to 0.02 times T is 0. So the answer is 30, and A is in thousand, so multiply by 1,000. So the population is 30,000. Next question. What will be the population in 2017? We need to find A for the year 2017. To find T, we subtract 2017 and 1995, and we will get T equals 22. Hence, A equals 46.5813. Then multiply this by 1,000 since it is mentioned in our problem that describes the population of a city in the Philippines in thousands. So multiply by 1,000. So the city population is approximately 46,581. Number 2, computation. So to find the population in 2017, so we just subtract 2017 minus 1995, and we will get T equals 22. So to solve the total population, we have we have 30 times E. For E, shift natural log. So raised to 0.02 times 22 years. So that is 46.58 something, and multiply by 1,000 since or A is in thousands. So the total population in 2017 is 46,581.27. So let's try this, class. Substitute the given values in the formula A equals P times E raised to RT to find the missing quantity. So for number 1, P equals 680,000, R is 12% per year, and T equals 8 years. You can pause the video and try answering this in a sheet of paper. Then later, I will reveal the answer. For the answer in number 1, substitute the given values in the formula A equals P times E raised to RT to find the missing quantity. So given are P equals 680,000 for R, that's 12% per year, and T is 8 years. So we will use the formula A equals P times E raised to RT. So substituting the given values for P, we have 680,000 times E raised to RT. So R is 12%. So converting it into decimal, that's 0.12 times T is 8 years. So using our calculator, let's compute it. It's 2.12. Okay, so the answer is 100. Okay, that's 1,775,953.6, or approximately that's 1,775,954. Another one, substitute the given values in the formula A equals P times E raised to RT to find the missing quantity. So for number 2, A is equal to 1,240,000 and R is equal to 8% per year, and T equals 30 years. Again, you can pause the video and later I will reveal the answer. Problem 2, substitute the given values in the formula A equals P times E raised to RT to find the missing quantity. So for number 2, we have A equals 1,240,000. For R is 8% per year, and T is equal to 30. So the missing variable in our formula is P. So using our formula, A equals P raised to ERT. We just substitute the given. So A is 1,240,000 equals P times E raised to R is, converting this one to decimal, that's 0.08. Just divide it by 100 times T is 30. So to solve for the unknown, we will just divide both sides by this. So E raised to 0.08 times 30. So we will have P equals 1,240,000 over E raised to 0.08 times 30. Then calculate it in your calculator. Okay, the answer is, what's the answer? $112,490,000. Okay, so this is the answer. Okay, so that's all for today. Hope you learned something, class. And just like the video and subscribe this YouTube channel, and wait for our next lesson.